For this example, we're going to use y equals negative x cubed plus 3x squared minus 2. We're going to figure out where it's concave up and down and see if there are any points of inflection. So if we take the first derivative, we get y prime equals negative 3x squared plus 6x. If I take the second derivative, because that's what will tell me about concavity, I get negative 6x plus what?
6.
Plus 6. So there's my second derivative. That's what I'll use for my test numbers. See if they're positive or negative. Then I need to find the critical number, so we'll set that equal to 0. So did you guys get x equals positive 1?
Yes.
Yes? That's the only place where we'll break our number line. So we have positive 1. And if we substitute in 0 to the second derivative right here, we get positive 6. And if I substitute in 2, I get negative 6. So it looks like it is concave up for the first part and down for the second part. All day. Is there an inflection point? If so, where does it have to be?
1, 0.
At 1 something, right? So if we take positive 1 and we substitute it into the original, what do we get? You get 0? So there's your inflection point. And you could just graph that and take a look at the original and make sure that that looks right. Probably we could just graph it right now, with, like, if we think about it, right? If we have a point at 1, 0, and we know it's a cubic, right? Yeah? And it's a negative cubic? Yes?
Yes.
Does it look like that?
Sure.
Does it?
Yeah.
Concave up? Concave down?
Yeah.
Yeah. Yes.
Concave up.
So for this example, we have to do the quotient rule twice. So we do it the first time, and here's what I came up with. Y prime equals 2x squared plus 2x plus 2 all over 2x plus 1 squared. And you could have factored a 2 out, but it didn't do me any good, and I didn't want to leave it factored out for the second derivative, so I just put it back in. Is everyone okay with the first derivative? If you got a minus 2 right here, it's because you forgot to distribute the minus 2 in that step there to the minus 1. So a lot of people make that mistake.
Is that a plus 2?
It is. Here, I'll pause for a second. So for the second derivative, we have low d high minus high d low, which turns out to be, let's see, this, all over low low. So I'll give you a second to see if you made it that far. This is low, d high minus high, and this is d low. Don't forget the chain rule in there. All over low low.
Yeah.
Okay, now we can factor out a 2x plus 1, right? That's all we can take out, a 2x plus 1. So the 2x plus 1, and we are left with a giant bracket of 2x plus 1 multiplied by 4x plus 2. All right, and then the 2x plus 1 here was taken out, so we're just left with minus 4 times all of that. Now I'm going to go ahead and distribute that minus 4. So we have minus 8x squared minus 8x minus 8. And I guess that's the end of our bracket. We can go ahead and reduce by a power of 2x plus 1, right? Okay. And then we'll have to FOIL these two guys out so that we can combine like terms. So what I got when I did that was 8x squared plus 8x plus 2, right? minus 8x squared minus 8x minus 8. All over 2x plus 1 now to the third power. So we're getting there, slowly but surely. And look what happens to the x's. They're all gone, and I'm just left with,
-6.
is that a minus 8?
Yes.
Yeah.
Yes?
Yes.
Okay, cool. So what does that give me?
-6.
-6 all over 2x plus 1 quantity cubed. So all of that work came down to there. No,
It's better than having a bunch of random
That's
shit.
true.
yeah, I do kind of like that it cleans up a little bit.
This makes me just want to go on.
What's going to be our only critical number there for the second derivative?
-1/2.
-1/2, right? The top's not going to go to 0, and if we take the bottom to 0, we get -1/2. And that's going to act as a vertical asymptote. You should be able to see that right there. Do you see it in the original, that that's a vertical asymptote? So take -1/2, and we substitute in, I don't know, -1 or -2 and 0 in here, into your second derivative, and see if you get concave up or concave down for those. What'd you guys get?
Positive and then negative.
Positive here, and then you guys said you got a negative there?
Yes.
Okay, so it is concave up from -infinity to -1/2, and it appears to be concave down from 1/2 to infinity. And then let's talk about the inflection points. If it has one, where does it occur?
It's a negative one.
At -1/2, right? But what happens when you plug it back in?
Error.
You get an undefined when you plug into the original. So because of that, it doesn't have any inflection points. It can't be an inflection point and a vertical asymptote, and that point is producing a vertical asymptote. So there are none.
Negative.
Concave down.
So this should be a negative right there. Thanks. You guys, one more, okay? I saved the best for last. A little bit of trig just for you. We're going to determine all intervals on which the graph of y equals sine x plus cosine x is concave up or down. And we're just going to go between 0 and 2 pi, but we are going to find points of inflection if it has any. So for our first derivative, we have y prime equals cosine of x minus sine of x, right?
Yes.
But for our second derivative, we have negative sine of x minus cosine of x. Okay. So the question is, how do we find the important points from that? So what we do is we take that and we set it equal to 0 and undefined. Now sine and cosine can't be undefined, so we're just worried about where that equals 0. So negative sine of x minus cosine of x is equal to 0. And there are several ways that we could do this, but I'm just going to try to talk you through it with some common sense. Does that mean that negative sine of x has to equal positive cosine of x? Okay, forget the negative for a minute. Where's the only spots on the unit, where are the only spots on the unit circle cosine and sine are equal?
1,
45.
45 degrees, right? Okay, so that's going to be your reference angle. Okay, and so they can either be equal or they can be opposites at that point. Square root 2 over 2 or negative square root 2 over 2. I want to know where are they opposites. So I know it's not quadrant 1, because in quadrant 1, they're both positive square root 2 over 2, right? Okay, so this one's out. We can't use him. In quadrant 2, sine is,
Positive. So.
Yes, do you see?
and cosine is
Negative.
negative. So this would be true, right?
Yes.
Negative square root 2 over 2 would equal square root 2 over 2. So what is he? What point is that? 3 pi over 4. Okay, so there's one of our numbers. All right. In this quadrant right here, they're both negative, right? So that's not going to be true,
It's me.
right?
No.
Because that would be
Yeah.
negative
Then
square
that'd
root
be-
2 over 2.
Because
and that
tangent's
will be-
positive in that one, so they'd both be
Right.
negative.
So they're
Okay,
both
right.
negative. So they're not opposites there. So this guy's out. Over here, cosine would be positive square root of 2 over 2, and sine would be negative, but a negative would make them equal, right? 7 pi over 4. So those are the two numbers that we're looking for. Does that kind of make sense, you guys?
Yeah.
So we want them equal but opposite. And that's how we knew pi over 4. We had to pick the quadrants where one was positive, one was negative to make that negative sign equal that positive cosine. So we're just going to start at 0. We're going to run to 2 pi. And we'll break it at 3 pi over 4 and 7 pi over 4. And that does not look right. Let's try that again. And make sure that your calculator is in radian mode if you're using it to help you test the concavity. So I substituted in 1 radian, 3 radians, and 6 radians. And I got concave down, concave up, and concave down. So we'll do concave up first, which is 3 pi over 4 to 7 pi over 4.
Well, you were supposed to be in radians mode, right?
Right. And concave down, in calculus we're always in radian mode,
Bet.
is from 0 to 3 pi over 4, unioned with 7 pi over 4 to 2 pi. And we're not going to infinity because trig functions, they're periodic, so they're going to continue to change. So we just chose for one revolution there. And it looks like it has 2 inflection points. Let's see. We have 3 pi over 4 and 7 pi over 4. And I should plug those into the original, right. So let's see if we see. Sine of 3 pi over 4 plus cosine of 3 pi over 4. It is 0?
Yeah.
Well, that's nice. Okay. How about this guy?
I got a weird number for it, but it
2.
might be 0.
2.1
It says-
e negative 13.
It says
It's
2 with a
0.
negative
Yeah, it's
25,
0.
What?
Yeah, that's point 0, 0, 0, like
Yeah,
12 zeros, right. So yeah, that is also 0. And we could think about it, and we know that if we're in the 4th quadrant there, that's a negative square root of 2 over 2, and that's a positive square root of 2 over 2. So that's why they add to 0. So you should be able to do it either way, but you could verify with your calculator. Okay, so that is section 3.4. As you can see, the biggest burden is going to be getting the second derivative for most of these. Here is the assignment, just 1 through 25 odd.